treasure gold.
So I wanted to give this talk, timestamping election with Bitcoin. Oh, yeah, man. No, that is not my slides at all. There you go. I'll let them figure it out. So I wanted to give this talk, timestamping election with Bitcoin, for two main reasons. I mean, first of all, this is a blockchain conference, and so many of these other topics are kind of confusing. Talking about tokenization this, tokenization that, et cetera, et cetera, et cetera. And timestamping is nice because cryptographically, it's very simple. There's really not that much to it under the hood. And I'm going to try, there we go. I'm going to try to give you a sense of what really is going on mathematically. Of course, the other reason is my understanding is you guys have an election coming up on, February 1st, 2026? So you should actually take this advice and timestamp your election. But with that, let's start with, what is a timestamp? And I would describe it as carbon dating for data. And when you do carbon dating on, say, archaeological artifacts, what you are doing is getting scientific evidence of how old something is. You might go take an old violin and figure out, well, it's not recent, it's actually made of wood that's, 500 years old. Now, with carbon dating, yeah, there's some ways around it. But for the data version of this, we can get very, very good guarantees of how old something is. Or at least when it existed. So, why would you do this? Well, that right there is a time machine. And I don't know any bad guys who have a working time machine. And what this means in practice is if you can show how old a piece of data is, you can rule out bad things happening in that data after that point. Maybe someone breaks into the server room, and you know roughly when that break-in happened. If you have timestamps proving the data existed prior to that point, you're good to go. And there's a very real, concrete example of this that even Bitcoin Core uses, which is Git commits. Now, I'm sure you cannot read that, but that, if you know a little bit about programming, you might recognize that is a Git commit log. And Git is the software we use to go and store our code. This is very important because, of course, the code that you compile into software, if you can put a backdoor in that code, that's not a good day. So in projects like Bitcoin Core, we digitally sign our software. We digitally sign every single commit, every single change we make to it. But in this case, this digital signature is from a very well-known dev called Peter Wool, the much more well-known Peter in Bitcoin. And Peter Wool got his keys compromised a while back. Some bad guys have his keys. Well, we couldn't know directly if these signatures were created before or after his keys were compromised. If you have a timestamp on them, you can make that determination pretty easily. This is another Git commit on Bitcoin Core. This particular one is actually one of mine, just adding some called DNS seed to the list of seeds. Very, very trivial commit, but it is digitally signed by me, by my key, and it is timestamped. So no matter how many far years into the future, we'll always be able to say, hey, this thing really existed as of 2017. And if my key gets compromised, maybe 2027, we can go back and say, hey, obviously 2017 is a lot earlier than 2027, so we're good to go. Another example of actual use of timestamping is something called ProofMode. And I brought this one up because it's an example of application you can just download on your phone. I mean, it's an Android app. You just go to the App Store, download ProofMode. And what it does, among other things, is it timestamps photos and videos so that yes, this claimed photo really existed as of that time. Now, AI these days is pretty good at faking things. And there's certainly going to be cases where if you can say, hey, I created this photo prior to having any reason to fake it, that's convincing evidence that maybe it was in fact real. And ProofMode is one of a couple companies doing things like this. There's also companies doing this for copyright registration and so on. But they all kind of fall under this category of it's data, proved exists in the past, we're relatively good to go. And I've heard, although I haven't actually been able to verify this myself, that war crimes investigators, as an example, are using ProofMode all around the world to just document war crimes photos and videos that they take. Obviously, a lot of these investigations are going to take years to actually get through the court system, and if you can go prove you haven't modified anything since then, you're in a better place in court. All right, so we've motivated why we would want to timestamp. Now we got to ask a question, well, I mean, how does it work? I mean, how can we actually do this? And this is where the math gets in. And none of this math is very hard. And if you think through it step by step, you can understand how it works. So first of all, timestamping is based on this idea of a commitment operation. We have a mathematical function that's proof that a message M1 existed prior to a message M2. Now, this doesn't say anything about what time anything existed yet. It's just saying, yeah, if you have this message M1, if you made a change to it, this other message would have to change too. You know, we're showing one leads to the other, basically. All right, so a really trivial example of commitment operation is like append and prepend. It's the operation of saying, I have a message, and I'm just going to add something to the end of it, or I'm going to add something to the beginning. Very trivial example, and it works because the message M1 is inside of the message M2. Very trivial. Obviously, if M1 changes, M2 must change. There you go. Hello, hello world. Not very interesting. Hash functions are the much more interesting commitment operation. They're really like how Bitcoin and blockchains like it are built. And a hash function, the way to think about it is it's as though you have a magical oracle in the sky. And this godlike oracle has a massive database of every single message that could ever exist. Clearly, this oracle doesn't exist. We simulate this with a bunch of math. But if that oracle did exist, you could go and bring them up on your cell phone and ask them, hey, what is the hash digest of my message? And if this oracle picks those hash digests at random, you have a mapping between every single thing out there, everything that could ever exist, and a subset of messages. Here's the trick. If a hash digest is smaller than the message, but not too small, it's kind of like a lottery in that every time you have a message, you just get this random thing back. Now, clearly, if that random message, the digest, is smaller than the input, obviously there's going to be examples where two inputs have the same digest. But if the digest size is big enough, we human beings can't find one because we don't have the computing power. The numbers we're talking about here is 256 bits. So think 2 multiplied by 2, 256 times in a row. Now, for reference, like the number of atoms in the observable universe is something on the order of, 2 to the power of like 260 or something, 240. I forget the exact number. You can look it up on Grok, I'm sure. But it's really big. Like, there are far less grains of sand in the world than there are bits, or there are possibilities in hash digest. We're never going to find 2 messages with the same SHA-256 digest. Just not going to happen. And that means it's commitment. If you know the output, it proved that the input was generated earlier because there's no other way to do it. Finally, we can combine those two into what's called Merkle trees. So if you take digests and concatenate them together, then hash them again, concatenate the results together, hash them again, you create a way of taking a large number of things and ending up in a commitment that's a small number of things, a small number of bits. Now, concretely, that means we can take all the world's data, all the world's requests at once, and timestamp it with, say, 1 Bitcoin transaction. Or, if you're a little more old school, I don't know, maybe go put the resulting digest in like a newspaper. And this gets back to the final part of a timestamp, which is attestations. Because everything I talked about up to this moment doesn't actually tell you what time anything was. All right, these are math operations. They say A existed prior to B. But they don't say, how does this relate to like real world human time? Now, a newspaper has a date on it. This particular one Friday, July 17th, 2009, a little after Bitcoin was created. And the company, Guard Time, is actually famous for operating one of the, probably the very first large-scale blockchain. And this was actually to go and do auditing of their timestamp system. And they would go and take your data, hash it, and they basically tell you, yeah, I have this digital signature claiming that this date existed as of this point in time. But because you wouldn't want to trust just Guard Time, then they'd publish hashes of hashes of hashes with Merkle trees in actual newspapers. Of course, verifying something by going to a library and like finding archives of old newspapers, who wants to do that? We can just use Bitcoin. Gets back to my software, Open Timestamps. And that's a tool, protocol, plus publicly available infrastructure that lets you, for free, timestamp your data. And long story short is when you timestamp data with Open Timestamps, what you get back is a math proof that ultimately leads to a Bitcoin transaction. And since Bitcoin transactions are in Bitcoin blocks, and Bitcoin blocks contain a time field, you have strong evidence that your data existed prior to that point in time. And the only way to go break that would be either break the math behind Bitcoin itself, or like reorganize the Bitcoin chain in a way where no one noticed. Now, even in a crowd like this, going to a like blockchain conference, I'm sure there's at least someone else in this room who's running a Bitcoin node. Like all those thousands people running Bitcoin nodes, if you try to modify Bitcoin to fake timestamps, people are going to notice. Very unlikely anyone's going to get away with this. So, we've established we can timestamp data. We can do it for free, basically. Not that hard. You just go, literally you can go to opentimestamps.org on your phone and just timestamp something. And it's nice and easy. Well, what can we do to timestamp an election? Well, so let's talk about the Guatemalan election from 2023. Now, Guatemala, like Costa Rica, is a paper ballot system. My understanding is the way the whole Guatemalan system works is actually nearly identical to Costa Rica. So yet one more reason to go try to pitch you guys on this. But being a paper ballot, you mark who you're voting for, and you stick it in a box. At some point, those boxes get opened after polls closed, and people start counting the ballots. That leads, one more thing. Fun bit of security there. Of course, you do the finger and ink thing to make sure you don't vote twice. But you wind up with your tally sheets, sum sheets, of how many people voted for what candidate in a given box. And that's a real physical piece of paper. People actually go right on, sign it. And in the Guatemalan system, at some point, once they've actually signed everything and they've checked off on it, these tally sheets get scanned in. And the scanning was the part where we timestamped. So every time these things got scanned in, sent to the central database, we also timestamped them. And you can actually see me right there as an official election worker at election headquarters, just frankly actually sitting around and like making sure Open Timestamps was running fine. Third party, I know of a company called Simple Proof, which Guatemalan, they'd actually contacted me saying, hey, we're about to go timestamp an election. You want to just be here and like babysit the stuff and just make sure everything's okay and answer some technical questions? So they did all the hard work. I got to go sit in the chair. But that was all good and fun. And they even used Simple Proof, again, based on Open Timestamps, to like, in front of the entire Guatemalan media, go timestamp the official document saying, yeah, we've actually started. That, of course, mostly ceremonial. If everyone in the whole country sees this on, on media, that's a pretty good timestamp in itself. But it was, a fun thing to do. So that was all cool. Unfortunately, the ruling party lost the election. And I don't have enough time to go into full details, but all the stuff that happened there. But suffice to say, the security of the election was questioned very vigorously. And the fact I'm here 2 years later talking about court cases that are still ongoing is a little nuts. But long story short is the party who I think everyone agrees should have been elected did get into power, but it was a bit of a fight. And It was a bit of a fight in multiple ways, but one of the ways was the time fields in the photos taken by the scanners. And this is an interesting thing because this, one way to look at it is maybe this is an innocuous error, maybe it isn't. Now remember, in like a .png file or .jpeg or .tiff, lots of these file formats, they have a field which allows you to put what you claim the time the photo was taken. And claim is a really important word here. It's just a field, it's just bytes. You know, you can open up it with a binary editor and just change those bytes to anything you want. And in this case, what we think happened was those bytes were ultimately set by a computer that ultimately has a clock, and that clock, if you set the time zone wrong, is not going to put the right time in the right place. That's one theory. Now, another theory put through the court system was, well, what if this was election fraud? Like, what if people were trying to backdate results or something? And open timestamps did help here because we had an entirely different source of truth here, which is that's the simple proof ultimately through Bitcoin times, and basically all of them were when you would expect. Polls close, 30 minutes, maybe an hour later, they're done counting. That's roughly when the photo should be made. And our second set of truth did indicate this. And it also really importantly showed that if all these results, they're all coming in, and they're all coming in when you expect them, so clearly we can also rule out people changing things after the fact, like well after the election ended. And my understanding is currently these court cases are coming to an end, and yeah, everyone's just accepting, yes, the election really did go off fine, and we're good to go there. Now, another one I want to talk about is we did manage to get timestamping into the 2024 presidential election on a much smaller scale. This wasn't like, in Guatemala, it was done sort of top down, namely the election authorities decided to go do this. 2024 was actually bottom up. And this, I think, is interesting. So, in Screven County, Georgia, who I'm sure no one in this place has heard about unless they know about open timestamps, the person in charge of the elections there in that county decided, you know what, I want more assurance that no one can go after me and say I falsified something. And all she did was she got a simple proof account, you know, the third party who kind of wraps open timestamps for you, makes it easy. She paid $15 for the count and then took the election documents that she was certifying as true, and when she created them, she timestamped them. Is that perfect security? No. I mean, obviously, maybe she falsified them at the beginning, but it helps make her case if anyone says something afterwards saying, we think you falsified this after the fact because of this. At least she has one more independent source of truth saying, yeah, I did my job when I was supposed to do my job, and that's that. Another very interesting thing here was prior to the election starting, you have to nail down what the voter list actually is. Because surely, of course, if you're able to change the voter list after the fact, there's all kinds of shenanigans you can do. And there's a really hard deadline to when the voter list is supposed to be set. Again, she took that list, she timestamped it. Now, I'll be the first to tell you, there's a lot better things we can do than purely timestamping here. But remember, all she had to do was sign up for an account, pay $15, and then Simple Proof just handles it. Or if she'd just gone to opentimestamps.org, she's just could have drag and dropped her voter list on the website, gotten a math proof back, and she'd be done. It really is that simple. So with that, thank you.
My sorrow into treasure gold.